Hi class, welcome to another video lesson. We're on the last video lesson for the first section of chapter 6. This is problems 3 through 8 on our notes for today. And what this video lesson is about is factoring these different trinomials, these quadratic equations, and by factoring them you find two things. The first thing is you find a solution for x. When you get x by itself, you can substitute that back into the equation, and you get the left side to equal the right side. What that means is you get a value for x that satisfies the equation. The second thing that you find is you find where the roots are of your graph. Roots, solutions, zeros, they're all words that mean the exact same thing. What you find is where it crosses the x-axis on a graph, and I'll go more into that in just a bit. So this lesson really isn't too different than what we did in chapter 5 when we factored a bunch of trinomials. Chapter 5 was just kind of the practice for the application that we're going to be doing today. You might not have saw too much of a point in chapter 5 why we were factoring. Hopefully now in chapter 6 it all makes sense and why we did that much practice on factoring, because it makes finding our solutions much more simple here in chapter 6. So for number 3, we want to factor this so we can solve each trinomial. So when we factor, remember, the first thing we do is we see if there's a GCF that we can take out. There is not, so once there's no GCF to take out, you form these two parentheses and you try to make the first times the first to equal this term. So obviously x times x is x squared. Now you got to think of factors of 30 that when you add them up give you 11 here. And I think that's quite obvious. 6 times 5 is 30 and 6 plus 5 is 11. So it's x plus 6 and x plus 5. That equals 0. Now here's the rationale behind this part. Hopefully you understand that the factoring part, that's pretty basic. Now once you get it to here, if this whole quantity in red equals 0, 0 multiplied by anything equals 0. So then we would get the left side equaling the right side if 0 equals 0. So when does this whole red quantity equal 0? When does x plus 6 equal 0? Well, if you subtract 6 from both sides, x equals a negative 6. If I put a negative 6 in here, I would obviously get a 0, and 0 times this, 0 times anything, is 0. So that's one of our answers. X equals a negative 6. Now for quadratics, there are always two answers. Whenever you look at your degree or your highest power of x, you see it's x squared. That tells you exactly how many zeros there are. In chapter 7, we're going to talk about polynomial functions. If your degree is x to the 5th, you should get 5 answers, or 5 zeros. If it's x cubed, you should get 3 answers, so on and so forth. Your degree tells you how many answers there are. So in chapter 6 here, most oftentimes our degree is 2, so we should get 2 answers for these. The other one, if this equals 0, then 0 times anything is 0. So we want to find when does x plus 5 equal 0? Well, if we subtract 5 from both sides, we get x equal a negative 5. These are your two answers, class, and at this moment you can move on to the next one. I'm going to stress one thing here. What you found here are solutions that satisfy this equation. So if you wanted to, and I push this maybe a little bit more than I should sometimes, but if you want to, class, you can check your work on every single one of these that you solve. You found a value for x. We'll just try a negative 6, for example. A negative 6 is x. So a negative 6 squared plus 11 times a negative 6 plus 30, that equals 0. This green sentence that I just wrote should make a true statement if you did it right. You should get the left side equal to the right side if you did it correctly. If you don't get the left side equal to the right side, that's a great check. You've done something wrong. So it's a wonderful thing that you can do if you want to check your work. We'll just prove it here with this one. A negative 6 times negative 6 is a positive 36. minus 66 plus 30 equals 0. 30 and 36 is a positive 66. 66 minus 66 is 0. 0 equals 0. So it checks out. You know that you've done it correctly. So you know that one of our answers is a negative 6. If you were to substitute in a negative 5, you would get the exact same thing. So the application behind factoring to solve, one thing you did is you found solutions, two solutions that satisfies the equation x squared plus 11x plus 30. But almost more valuable, I'm going to erase this. You guys don't erase this because it's part of the answer, obviously. I just don't want it to get in the way of the graph. If you were to put this into your graphing calculator, instead of 0, y equals x squared plus 11x plus 30, here is what your graph would look like. And hopefully you see the significance of this. And here it is right here. The zeros, when we find x equals a negative 6 and x equals a negative 5, like I said, you find what are called zeros of the equation or zeros of the graph. You find solutions, you find the roots. All those words mean you find where it crosses the x-axis. Here's the origin at 0, 0. This crosses at negative 1, 2, 3, 4, 5. As well as negative 6. This blue parabola comes down, it crosses at negative 6. It comes back up and crosses at negative 5. Which is exactly what we got when we factored. X equals a negative 6, x equals a negative 5. So for numbers 4, 5, 6, 7, and 8, the application behind factoring isn't just to make those two binomials and then call it good. You solve those two binomials when x equals 0. Why do you do that? You want to find values that satisfy your beginning equation. You also want to find where our graph crosses the x-axis. So that is the benefit behind factoring and solving. All right, number 4. Can we take out a greatest common factor? We cannot. So we just get our two binomials that equal 0. I know that 5x multiplied by 1x is 5x squared, so that takes care of this. Factors of a negative 6 that are going to give you a negative 13. If I have a negative 3 here and a positive 2 here. Let's do a quick check. First times the first, 5x times 1x is 5x squared. We'll do the last times the last. 2x times a negative 3 is a negative 6. So now the outside and the inside terms have to give us this negative 13. Negative 15x plus 2x is a negative 13x. So we got that one done correctly. All right. So now each of these factors we have to set equal to 0. So 5x plus 2 equals 0. And x minus 3 equals 0. Let's solve both of these for x. By subtracting 2, we get 5x equals a negative 2, and dividing by 5, x equals a negative 2/5. There's one of your answers, and then our other one is obviously just adding 3 to both sides, so x equals a positive 3. Those are your two answers. So class, if you want to, you could substitute them back in for x, and you would get 0 equals 0. Another thing you found is you found that the graph crosses at a negative 2/5 and crosses at a positive 3. Right here, negative 2/5. Here's my origin, 0, 0. So it crosses at a negative 2/5. And it crosses at a positive 3. So class, just by doing maybe a minute or 2 minutes of work, you can really find a lot about a parabola. You know that this is an x squared equation, so you know that it's going to be a parabolic shape. You know that your coefficient of a is positive, so you know it's going to open up. And then, just by factoring it, you know where it crosses the x-axis. So you know where this point is and this point is. You could also do another maybe 20 seconds of work to find the axis of symmetry And then to find the vertex, you can know it could be down here. So you know quite a bit of information, all in a matter of about a minute when dealing with these quadratic functions. Number 5. We always want to get it into the form ax squared plus bx plus c equals 0. You want a 0 on the right side. So if you want a 0 on the right side, let's subtract 16x first. So putting it into descending order, x squared minus 16x plus 64, that equals 0. Now we'll factor. This is going to be x minus 8 times x minus 8. X times x is x squared. A negative 8x minus 8x is a negative 16x. And a negative 8 times negative 8 is a positive 64. So it's factored correctly. But never ever stop here. You always want to find what x equals. We're solving. Solving is isolating the variable, getting x all by itself. So x minus 8 equals 0. And x minus 8 equals 0. As you can see, there's something a little bit fishy about this one. X equals 8, and x equals 8 when you add 8 here to both sides. So class, what I told you is I told you that your degree tells you how many zeros you have. And yet on number 5, we get the same answer. X equals 8 and x equals 8. So really that is just 1 0, isn't it? This is a very particular case where you have x equals 8 as your answer, and what I want you to put underneath it is dr. dr stands for a double root. So x equals 8 is a double root. And here's what a double root looks like when you put it on your graphing calculator. You know that this one, here's our equation. You know that it's a parabola, and you know that it's going to go up. And what a double root means is that it doesn't pass through your x-axis. It hits your x-axis, and then it hops right back up again. So x equals 8 is our answer. So as you can see, here's 0, 0. It crosses at 1, 2, 3, 4, 5, 6, 7, 8. And I shouldn't say it crosses. It comes down, and it hits my x-axis at 8. It doesn't pass through it, though. It goes right back up again. So when we have two solutions, it means that it comes down, passes through, and then hops back up again. Or if it were to come, if it would be a parabola that opens down, it would come, hit the x-axis, come up, and go back down again. When it's a double root, it does not pass through the x-axis. It only touches it and hops back up again. So whenever you see a double root, that's what that means. It means that it does touch the x-axis, but it doesn't pass through it. Okay? As you can see, this one, it stays above that fourth quadrant right there. So if you ever see a double root, in that case, it doesn't pass through the x-axis, it just touches it. Number 6, let's get everything onto the left side. So I'm going to add 5x here. 6x squared plus 5x equals 0. As you can see, there's no constant term in this one. This one fools a lot of people because they forget the very first step, and that is, let's see if we can take out a GCF. This has an x in it, and this has an x in it, so I can factor out that x. So I factor out an x, and what am I left with? 6x and a positive 5. If you're unsure of yourself at this point, just quickly distribute this back. X times 6x, 6x squared. X times 5, 5x. So you didn't change anything. All you did was factor out that x. All right, so now what you have, class, is two factors where if they equal 0, the whole left side equals 0. So when does this factor equal 0, and when does this factor equal 0? Well, you simply solve both sides for x. On this one, it's already done. X equals 0 is one of our answers. If x is 0, the whole thing is 0. For this one, we have to subtract 5 first. and then divide by 6, so x equals a negative 5/6. So we have two answers once again. If we were to look at the graph, it would cross at 0 and a negative 5/6. Here's our negative 5/6, and here it crosses at 0. And there's our graph. Number 7. On this one, very similar to the last one, you don't have a quadratic on this one. What you actually have is a cubic function. We're going to talk much more extensively about this in chapter 7. When we have an x cubed, that tells you how many zeros we're going to have. We should have 3 answers when we're all done. The reason for that is because our degree is cubed. So this is a polynomial function, and to be more specific, it's called a cubic function. Very first thing, take out the GCF and then factor and solve. So we have an x cubed, an x squared, and an x. If that's the case, we can take out an x right off the bat. And now we're left with x squared plus 12x plus 32. That equals 0. Now, this trinomial, you can factor that. So you still have this x on the outside, and now you're going to have two different binomials. X and x, factors of 32 that give you 12, are a positive 8 and a positive 4. So now, class, what you have is you have 3 factors where if any one of those factors equals 0, the whole left side turns to 0, because anything multiplied by 0 is 0. So if you want to find your answers, you got to set each factor equal to 0. So my answers, x equals 0, x equals negative 8, x equals a negative 4. So we do indeed get 3 answers, and we get that because our degree is 3. Our highest power of x is 3. So if we look on our graph should cross at 3 different times, which once again, class, I want to be very clear, this is not a quadratic function. Quadratic functions are always parabolic shape. They form a parabola, that U shape. And quadratic functions only cross the x-axis at most 2 times. This one crosses the x-axis 3 times, so it looks certainly a little bit different. It looks like this. Now what this is it probably our graph, let's see, here's the origin right here. Our graph only goes up to 10 and down to a negative 10. So what I'm guessing that you're seeing is you're probably seeing a function that starts way down here at negative infinity. It comes up, and then it probably has a little hump right here, and then it comes back down again. Same thing over here. It goes down, and then it humps back up through, and then it goes all the way up to positive infinity. So we'll deal with that more in chapter 7. We won't worry about it now. For now, just make sure that if you see an x cubed, if you see, wherever my equation went, if you see an x cubed term right here, you know that you're going to get 3 answers, which means that it's going to cross the x-axis 3 different times. All right, last one. X squared minus 16. If you look at this one, it doesn't have an x term. It doesn't have that b value. But you can still factor it. This one's called the difference of 2 squares, which if you remember on that one, it's x minus 4 and x plus 4. These two quantities are also called conjugates, if you remember that term. So when we factor it to x minus 4, x plus 4, we know that both of these are factors that when they equal 0, that gets us our solutions. So adding 4 here, x equals 4. Subtracting 4 here, x equals a negative 4. So I want you to look at this one for a second before we look at the graph. If we were to do our axis of symmetry, which is a negative b over 2a, there is no b value. This can be written as x squared plus 0x minus 16. There are no x's. So it would be a negative 0 over 2 times 1, which 0 divided by anything is just 0. So my axis of symmetry is x equals 0, which is the y-axis. It's a vertical line at 0. So if my axis of symmetry is the line x equals 0, my vertex lies on that axis of symmetry, as we learned in an earlier video lesson. So it's going to be symmetrical to the y-axis, and it's going to cross at -4 and a +4. So as you can see, my vertex is indeed right on the y-axis. There's my vertex. It's right on the y-axis. Here's my line of symmetry at 0, and it crosses at a +4, and it crosses at a -4. So that kind of ties in a lot of different things with factoring, with solving, with finding roots and solutions. It really is a good lesson to tie in a bunch of things that we've been talking about in previous lessons. So here's what we have for homework. Oh, before we have homework, I want to warn you about what you might see in Excel math. I think on this one, it just asks you for the domain and the range. So what you can do on this one is you can just solve for y. So if you were to solve for y, subtract 5 from both sides. X minus 5 equals y squared. The reason why you would solve for y, class, is because you have a y equals button in your calculator. Let me pull this up here. Takes a little while to load. Hey, yeah, there's my wife and my son. Aren't they cute? Where's my calculator at? Alright, so getting back to this. It has a y equals button on our calculator. So we can only enter in y equals functions. We cannot enter in x equals functions. So now, if I were to solve for y, taking the square root of both sides, I would get y equals, when you square root something, you have to have both the plus and the minus. So y equals the plus and minus square root of x minus 5. This, class, you're going to put into your graphing calculator, which my graphing calculator never showed up. Why? That's maddening. Wow. Sorry about that delay, class. I don't know what happened here with my smartboard, but we'll just do something here really quick again. I apologize again for that delay. But we solved for y here. So we had x minus 5 equals y squared. And then we would get the plus and minus square root of x minus 5. That equals y. So what we're going to do is our calculator only enters in functions. And so because if you put this in, you're going to get a sideways parabola, which is not a function because it doesn't cross the vertical line test. So we have to put these in separately. So under one line, you're going to put in y equals the square root of x minus 5. and under the other one you're going to put in y equals the negative square root of x minus 5. So I'll show you how to do that. You're going to press y equals in your graphing calculator, which is the top left button. Y equals the square root, so second x squared button, of x minus 5. And then under this y2, so your second line, it's going to be the negative. Make sure you press the negative button there and not the minus button. That makes a big difference. The negative square root of x minus 5. If you graph these two now, as you can see, you get a sideways parabola. And I believe, once again, you're not going to see this on a worksheet. You're just going to see this in Excel math where it asks for the domain and the range. So as you can see, your domain, when does it start touching? It starts touching right there. So your x values, they start when x equals 5. So right here. So it starts at 5. This is your domain now. And it goes all the way to positive infinity, which means that you're going to have x such that x is greater than or equal to a positive 5. And then for your range, this goes down and to the right forever and ever and ever, and this goes up and to the right forever and ever and ever and ever. So that means that your range, if you take this vertical line, it hits the red, it hits the red, it hits the red, it hits the red, and all of these horizontal lines will continue hitting the red. So that means that it's all real numbers, or it goes from negative infinity all the way to positive infinity, which, like I said, means that it is y such that y belongs all reals. So now your assignment. You're going to have 5 objectives, sorry. And then you're also going to have a short worksheet that has 4 problems on it that that is a practice one that teaches you how to graph quadratic functions. So you have 4 graphing problems, and then you have 5 Excel math objectives. Let me know if you have any trouble with those. Ask me questions when you need.